Hello guys, welcome to the studies on determinant of 2 by 2 matrix. Determinant, the power of a square matrix. Now let's get to understand what a determinant is. So what is a determinant? A determinant is a special number calculated from a square matrix. And a square matrix is a matrix which the number of rows is equal to the number of columns. The determinant tells us the possibility of the matrix being invertible. What is the meaning of that? It means that it tells us to know, or it makes us aware that the matrix has inverse or not. Then in geometry, the determinant tells us about area scaling and orientation. Then in addition, if I want to write determinant, I need not to write the full word, but rather write a short word of the form DET, then bracket the letter representing the matrix, for example, A, where this A is a square matrix. So the A can be 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, and so on. Now let's look at this particular studies which based on 2 by 2 matrix. If A is equal to A, B, C, D, 2 rows, 2 columns, that is 2 by 2 matrix, and I want to find the determinant, then I'll write DET of bracket A equal to the leading diagonal AD multiplying themselves, then the next diagonal BC, that is the product between B and C, and the product of A and D, then minus sign between their results. So the determinant of A is equal to AD minus BC. Good. Now look at this particular image, that is a square with inside with square boxes of element A, B, C, and D. That is the reason why we said the determinant of the matrix is a special number calculated from a square matrix. So we have a square matrix with element B and C. If I want to find a determinant, then the first diagonal, there will be a product. You find the product of the first diagonal. Then you find the product of the next diagonal. Then you find the minus between them. So determinant of 2 by 2 matrix will be AD minus BC. Now let's look at an example here. We have given that A is equal to 3, 2, 5, 4, and matrix B equal to 7, neg 1, 6, 3. We are supposed to find the determinant of A and B. In doing that, this will be our solution. Determinant A equal to the leading diagonal, that is the 3 and the 4, the product of it. So the product of 3 and 4 will be 3 times 4. And the product of the next diagonal, 2 and 5, will be 2 times 5. Then the minus between them will be our determinant. So 3 times 4 is 12. Then 2 times 5 is 10. So the minus between 12 and 10 is 2. Then determinant of B, we are going to repeat the same process, which will be 7 times 3 here. Then 6 times negative 1. Negative 1 times 6 will be here. Then the result will be 21 minus 6. And minus will give us positive. So 21 plus 6 will be equal to 27. Now, let's continue with another unique example to expand the understanding. We have A equal to matrix of the form 4 minus 2, 3x, and 5. We are supposed to find the value of x if the determinant of A is 32. Now let's look at this solution. We have given the determinant of A to be 32. Then it means that if I want to find the determinant of this matrix, first I'll find the product of the first diagonal, then find the product of the next diagonal, then I'll subtract the product of the next diagonal from the product of the first diagonal. So here 4 times 5 is the first diagonal, the product of it, and the product of the next diagonal is minus 2 times 3x. So when you do that, we are going to have the determinant being equal to 20 minus 6x, which is the same as 20 plus 6x equal to 32, since the determinant is 32. So we have the determinant expression and the determinant value. So we equate the results to find the value of x by making x the subject. So 6x will be equal to 32 minus 20. Then the 6x will give us 12. Divide both sides by 6 and x will be 2. Now let's look at another example. This time the matrix is being presented in a determinant form. So look at this bracket and look at this identification. You realize that there are two symbols. This one is a bracket and this one is not a bracket. Now this one represents determinant sign. So here it means that the matrices, the element or the entries of the matrix, we are supposed to find the determinant of it. So if the expression is of this form, we should determine the value of x, which means that we should find the determinant of this expression, then find the value of x. Here they are telling us that the determinant is equal to 0. So in this case, we are going to equate the expression given to us to 0. Indeed, it is even equated to 0. So it means the determinant of this matrix is equal to 0. We are going to multiply the leading diagonal and also multiply the next diagonal. And doing that, we are going to get x minus 2, x minus 3, minus 1 times 2. When we expand and simplify, we are going to get x times a being x squared, x times this being minus 3x, minus 2 times a being minus 2, then minus 2 times minus 3 will be positive 6, then minus 1 times 2 will be 2. We group like them to get a quadratic equation. Then we solve the quadratic equation, and when you are done, your x will be equal to 1 or x will be equal to 4. So the moment x becomes 1, the determinant will be 0, or the moment x becomes 4, the determinant will be 0. Now, let's get to an application question on how we can apply determinant to solve a problem involving systems of equation. Now, example is in this form. We are going to solve the system of equations of the form 2x plus 3y equal to 8 and 4x plus 1y plus y equal to 10. So how do we solve this problem? The solution will be to let a be equal to 2, 4, 3, 1. That is 2, 3, 4, 1. Where did we get this 2, 3, 4, 1 from? They are the coefficients of the unknown variables in each of the equation. So when you look at the matrix A, 2 is the coefficient of x in the first equation. 3 is the coefficient of y in the second equation. 4 is the coefficient of x in the second equation. And 1 is the coefficient of y in the second equation. So 2, 3, 4, 1 form 2 by 2 matrix. So first of all, we have to find the determinant of A. And the determinant of A will be 2 times 1 minus 3 times 4 leading diagonal, the product of it, minus the next diagonal, the product of it. So determinant A is equal to 2 minus 12, which is equal to minus 10. Now, here you need to understand that we have this matrix being equal to this matrix. And this is 2 by 2 matrix, and this is a column matrix. Where did we get this column matrix from? They are the end results of the two equations. So we have equation 1 producing 8 and equation 2 producing 10. Now, what is our next stage? Our next stage is to find the matrix A subscript X, which represents the matrix of X. In this case, we are going to remove the coefficient of the X and replace it with the results 8 and 10. When you do that, then you find the determinant of matrix A subscript X. And the determinant will be 8 times 1 being 8, then 10 times 3 being 30. Then the minus between them will give us minus 22. Then we repeat the same process by removing the Y column. This is the Y column, that is the X column. Then replace the Y column with the column of the results, which is 8 and 10. In doing that, you have a matrix of A subscript Y. Then you find the determinant, which will be 2 times 10, 20, 4 times 8, 32. Minus between them will give us minus 12. Then, what are we going to do next? Our X will be determinant of AX divided by determinant of A. What is the answer for determinant of AX? Minus 22. What is the answer for determinant of A? Minus 10. So minus 22 divided by minus 10, the result will be 2.2. Repeat the same process for Y. Determinant of Y divided by determinant A. And our expression is going to be minus 12 divided by minus 10, which will give us 1.2. So it means that we can use determinant to solve for systems of equation. Now, let's look at geometric interpretation of determinant. The determinant represents area scaling factor for transformations. And if determinant of A, where A is a square matrix, is equal to 0, then it means that matrix A is a singular matrix and has no inverse. So a singular matrix is a matrix with a determinant of 0. Then we also have to understand that if the determinant of A is not 0, it means the matrix has an inverse, and you can also see that it is invertible, and we call such a matrix as non-singular matrix. Now let's get to know some common mistakes to avoid. The first one is reversing the subtraction. Some students will be reversing the subtraction process. We have to understand that the subtraction is not commutative. So we need to maintain the position of each of the term. The product of the leading diagonal is supposed to be the first term minus the product of the next diagonal. Don't change their position. Now, we should also understand that we normally forget the negative sign. What is the meaning? Negative times negative is positive, and negative times positive is negative. So when we are multiplying, we should get to know that negative signs have effects on the results. Then we should also not assume that all 2 by 2 matrices are invertible. It means that there is a point that we can get determinant to be 0. Good. Then we should always follow the formula AD minus BC. Now there is a try work for you to try your hands on them. We have find the determinant of the matrix QP. Then here too you are supposed to find X and use determinant to solve the equations, that is these two particular equations. Thank you for taking part in this lesson. Don't forget to follow or subscribe to this particular channel to continue receiving the best of high school math education.